Okay, today's lesson is on parallelograms as we venture into polygons, specific polygons that is, called quadrilaterals. So we're going to talk about four-sided figures, and the first four-sided figure, quadrilateral, that we're really going to focus on and talk about their properties, and that's of a parallelogram. So we're going to find side lengths and angles, and we're also going to use the coordinate plane a little bit. So first of all, let's talk about the definition and what a parallelogram actually is. It is a quadrilateral with two pairs of parallel sides. So opposite sides are parallel, and hence that's why it's called a parallelogram. So you can see by the figure that QR and PS are parallel, and PQ and SR are parallel. Two pairs of parallel sides. Now, because of this, those opposite sides are not only parallel, but they're also congruent. So there are two properties, two things about parallelograms that we need to take into account with their sides. And that is that opposite sides are parallel and opposite sides are congruent. The third item about parallelograms is that the opposite angles are also congruent. So you can see that P and R are congruent and Q and S are congruent, and that is always the case in a parallelogram. Now, knowing this, we should be able to answer questions like the following. Find X and Y. Well, what is AB? It is the same length as CD, right? So it's 12. So if we're going to find X, we know that X plus 4 equals 12. Subtract 4. X is 8. Now we also know that opposite angles are congruent, so then obviously Y must be 65 degrees. And that's how we could apply those two theorems. Parallel lines again. Find FG. Well, what would FG be? Well, the same as HE, so it's 8. And what's the measure of angle G? 60. Opposite angles are congruent. On this example, find X and Y. Well, here again, Y plus 3 must equal what? 18. Subtract 3, you get 15. Angle L is 50, so what's angle J? 50, right. So 2X equals 50. So divide by 2. X is 25 degrees. So those are just some examples of how we can apply those three properties about parallelograms. Now, remember the consecutive angles theorem? If you don't, that's okay, because here's a picture. Parallel lines cut by a transversal, the consecutive interior angles are what we call supplementary. They add up to 180. And I think you remember that. We also called them same side interior. Well, why is this important with parallelogram? Well, remember parallelograms have two pairs of opposite sides parallel. So if you think about this then, here's a parallel line, here's a transversal. So these two are supplementary. These are parallel, right? Another transversal. Those are supplementary. Now, if you turn your head, these are parallel. No, sorry. These are parallel. This is a transversal, so these are supplementary. And likewise with these two. So in essence then, what we have here are consecutive, which means in a row, consecutive angles of a parallelogram are supplementary. So Q plus R is 180. R plus S is 180. S plus P is 180. And then Q plus P is 180. So that is the consecutive angles theorem. And then the last one, the last property, really, I call them properties about parallelograms, is that the opposite or the diagonals cut each other in half. They bisect each other all the time. So any parallelogram, if you draw in the diagonals, they bisect each other. They're not equal, but they cut each other in half. Okay? So to summarize then, I'm just going to write them right here. In a parallelogram, okay, you can draw the picture if you want, or you can, I hope you can draw a better picture than that. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the fifth thing, diagonals bisect each other. So that's pretty cool. And not hard to understand at all when you see a parallelogram. You can see these 5 things pretty clearly. So let's apply those 5 things here to this problem. It says we have a desk lamp, and the last little part here looks like a parallelogram. And angle BCD, or find angle BCD when angle ADC is 110. So I'm going to blow this up. So this right here is 110. We're supposed to find BCD, this angle. Well, if this is a parallelogram, are those opposite angles or consecutive? They're consecutive, right? So that angle then has to add up to 180 with 110. So angle BCD is 70. Okay. Another question, also using the figure at the right, find the measure of angle BCD when angle ADC is 2 times as big. So in other words, this angle is 2 times this angle. So this is 2x and this is 1x. Well, what do those add up to? Well, I know you're going to say 3x, but they're consecutive, so they add up to 180. So 3x equals 180 divided by 3. X is 60 degrees, so therefore BCD is 60 and ADC is 120. Okay. Now, this is the part where we're going to apply those 5 things to actual pictures here, and it's a lot of fun. Okay, and I would always suggest that you just fill in everything you can before you actually write out any of this stuff here. And it's in your notes there, so you can follow along and do it yourself as well. But obviously, if diagonals bisect each other, I'm going to work backwards here. That means that's 13 and that's 12, correct? Because they bisect each other. So let's see, EB or BE, where's EB? Oh, that's not, or ED, sorry. DE right here, that's 12. CE is 13, okay. Do we know CD? Okay, opposite side, well that's 10, isn't it? So CD's 10, so AD's 22, or DA. AC is the entire diagonal, 13 plus 13, 26. And BD is the higher, or DB is the entire diagonal, that's 24. So we took care of all the sides. All right, now look at all these angle measures, right? So many angle measures. But let's go ahead and just think about a parallelogram first. We know that opposite angles are congruent. Well, what is this whole angle? Well, it's 47 plus 23, which is 70. So we know that this angle is 70. So then we know that this angle is 110 because they have to add up to 180, remember? And this angle is 110. But that should tell us what this angle is then. Because, let's see, 110 minus 72, 38, because they got to add up to 110. Now, we know those. Now let's think about this. Parallel lines cut by a transversal. If this is 47 then this is 47 by alternate interior. That makes that 23. That makes this 72 and this 38. And I guarantee you we've got almost all these angles filled in. Okay, so let's start here. Angle ABC. ABC is the big angle B, that's 110. How about BCE? BCE, that's 23, that's already given. How about BCD? That's this big one, that's 70. How about ADC? ADC, that's the big one, it's 110. How about angle BAD? That's the big one, that's 70. CDE, CDE, I say that's 72. EDA, 38. DAE, DAE is 23. EAB, EAB, 47. Just trace it with your finger there. AEB, oh, this is a new one. How about this one, and this one, and this one, and this one? That's going to be interesting. Well, how do we find those? We haven't talked about those, have we? Well, they're all in triangles though, right? And how many degrees are in a triangle? 180. So if we're going to find AEB, that's this angle, we know that 47 plus 72 is 119, so that angle would be 180 minus 119, which is 61 degrees. But we also know then that the angle across from it, DEC or CED, is also 61 because it's a vertical angle. The other two angles then, we could add 38 and 23 and get 61, subtract it from 180, it's 119, and so is the other angle. So we just found every single angle here, knowing just 3 angles. We found them all. It's kind of fun. Hope you enjoyed that. Now, let's apply it some more. If that's a parallelogram, we know A is 9 and B is 11. If that's a parallelogram, we know that y minus 5 is 12. So we add 5. So y is 17. We know x plus 2 is 4. So we subtract 2, so x is 2. We know that 3x plus 4 equals 16, right? Opposite sides. So 3x equals 12. Divide by 3, x is 4. We know that y minus 60 is 56, opposite angles. Add 60, so that's 116 for y. Let's see, we know that 8g minus 3 would be equal to 25, correct? So we're going to add 3. So 8g equals 28, divide by 8. G equals 4.5. No, 4.53. Sorry. 3. Let's see, that would be 28 divided by 8. 8 goes in 3. Yeah, 3.5. There we go. And then F plus 30, it doesn't equal 72, does it? Those aren't opposite. But they add up to 180. So F plus 102 equals 180. We subtract 102, and we end up with F equals 78 degrees. Okay. Now we get diagonals. What do you know about the diagonals? Well, they bisect each other. So 3m equals m plus 8. Got to get the m's together. Subtract an m. You get 2m equals 8. So obviously, m has to be 8 divided by 2. 2n minus 1 is equal to 9. Add 1. 2n equals 10. Oops. So n is 5. And then the last example, same problem, same type of problem, not plus, equals. 3j equals 5j minus 9. Let's see. I'm going to subtract 5j and get negative 2j equals 9 divided by negative 2. So j is 4.5, not degrees, it's 4.5. And then 6k equals k plus 10. 5k equals 10, so k equals 2. Okay, so if there's any repeats you need, go ahead and stop it and go through the PowerPoint again, the video. But here are those 5 things we need to know, and we just applied them to those last 6 examples. Lots of